All right, let's look at 34 together. Try it first on your own and then come back for the solution. So what do we have? A group insurance policy covers the medical claims of the employees of a small company, and the value V of the claims made in 1 year is described by 100,000 times Y, where Y is another random variable with the following density function, given right there, where K is a constant. Calculate the conditional probability that V exceeds 40,000, given that it exceeds 10,000. So what we're looking for is the probability that V is greater than 40,000, given that we know it's at least 10,000 or more, greater than 10,000. Okay, this is a conditional probability, so it's going to be the intersection of those two, which really is just V is greater than 40,000, divided by V is greater than 10,000. Now we know that we're going to replace the V's with Y's and then work with this function, and it may be tempting to find K first, which normally if we want to find probabilities that involve Y, we would need to find K first, and we would do that. So let's say if we wanted to find K, we would take the whole K 1 minus Y to the 4th dy over the non-zero PDF and set that equal to 1 and solve. However, let's see if we actually need to solve for K. So here we have the probability that, so V is actually 100,000, Y is greater than 40,000, all over probability that 100,000 Y is greater than 10,000. Now we can solve for Y on both sides by dividing by 100,000. So this is really the probability Y is greater than 40,000 divided by 100,000 is 0.4. All over the probability Y is greater than 10,000 divided by 100,000 is 0.1. Now we use our PDF for Y here. So this is going to be 0.4 up to 1, K times 1 minus Y to the 4th dy. Sorry, this should be 0.4 up to 1. I don't know why I wrote there. 0.4 up to 1 over the integral from 0.1 up to 1 of K times 1 minus Y to the 4th dy. And those K's can come out and cancel. So I actually don't ever need to find K first. So definitely work through the problem if you're trying to do this in speed, and don't do unnecessary work. All right, so we're going to integrate the top, and we get 1 minus Y, negative 1 minus Y to the 5th over 5, because of that negative Y in there, from 0.4 up to 1, over, same integral, negative 1 minus Y to the 5th over 5, but this time from 0.1 up to 1. And plugging in, you end up with, so we end up with 0 minus a minus, so plus 1 minus 0.4 is 0.6 to the 5th, so 0.6 to the 5th over 5, over, and then again we plug in 1, we get 0, negative 0 if you want, minus a minus, so plus 1 minus 0.1 is 0.9 to the 5th over 5. So those cancel. So it's really 0.6 divided by 0.9 all raised to the 5th, which is about 0.13. And that tells us our answer is B. Did you get it?